Hello everyone, thanks Corey. Okay, so yes, so like Corey said, so we're going to be having a look at some tips and tricks for graph modeling. And with these types of things, I quite like doing a worked example and kind of taking that through and see how would we make the decisions as we go along. So that's what we're going to do for the next sort of 45, 50 minutes or so. So the first thing we need to do is work out what data set are we going to use. And maybe some of you have seen this already. This is a favorite data set of mine. So meetup.com, which hosts various technical and other meetups around the world, has quite a nice API that we can grab data from. And they actually make recommendations to people on that data. And so I thought, so for example, if you're a member, then you might have seen some of these already. So for example, when you go to a groups page, you might see a suggestion like this one on the left that would say, hey, people in this meetup are also in this other one. And it might suggest you like a group recommendation. Equally, it could be a specific event recommendation. As you can see here, I've been recommended the London R meeting in November. Or it could be a group recommendation, so saying, hey, I think you should join this group. And then on your homepage, you get a whole list of suggestions as well. And so I thought it'd be quite interesting to see whether or not we could write some queries that allow us to make recommendations similar to that using Neo4j and the Cypher query language as our toolkit. With the intention of having a look at how do we build this thing and what modeling decisions do we make as we go along. And obviously, with this data set, you can kind of see on the previous slide, there's a few different types of recommendation we could make. We could make suggestions of groups that people might join. We could make suggestions of topics they might follow, or we could make suggestions of events that they might attend. And obviously, we could do a combination of all those three. So we're going to have a look at two of those. We're going to have a look at groups that people can join and events that they can attend. And then what we're going to be obviously focusing from the perspective of a user of meetup.com, so someone who's attending events and trying to find new ones to attend. So here's just a little bit of a legend for you to keep track of what we're actually doing and where we are in the talk. So we're going to have this these set of icons in the bottom left-hand corner of the screen on every slide. And so what they mean, so the left-hand one, so it's a question mark, so that's suggesting that we've got some sort of business question, say, that we're trying to answer. And then obviously we need to figure out how we're going to do that, and probably the first step of that is going to be that we're going to have to get some data, and so that's what this second icon signifies. Probably at some stage we'd have to do a bit of modeling as well, like how are we actually going to model this data? How are we going to what are we going to do? There's obviously several different ways that we could model different problems, and then finally we're going to write some queries on the data, and so that's this icon over here. And so we'll highlight which one we're on as we go along the talk. So let's get started. So I thought my first question that I thought would be interesting to answer would be, as a member of the Neo4j London group, and obviously you could substitute any group in there. I want to find other similar groups so that I can join those groups. Okay, so simple enough. That's our first step. So we've got to work out what are we going to consider to make as our group similarity metric. And one way that we can do it is actually to do content-based filtering, and we can consider the topics that groups advertised as explaining the similarity between different groups. So, for example, if we look on the left-hand side, Neo4j has data mining, and it has open source, and it has graph databases, and it has Neo4j. Whereas if we come towards the middle, the deep learning group has computer science, has natural language processing, and then it has several other ones as well. And obviously, not every single topic is going to overlap between the groups, but there'll be some overlap, and we can use the knowledge of that partial overlap to make recommendations. Okay, so we know what we're going to use as our similarity metric. We know what question we want to solve. The next step is, can we figure out how we're going to model this? And the first thing to keep in mind is that we're only modeling for that question at the moment. So we only need to answer this question, so we only need to pull in this data. So as a member of the Neo4j London group, so that suggests we need a group. So that's the little circle over here. And then we're saying I want to find similar groups. And remember, we said that similarity is going to be by topics. So we'll just quickly go through what do each of the bits of this diagram mean. So the circles here, those are our main bits of data. So in this case, at the moment, we've got groups and we've got topics. And those would be equivalent to the records in your relational database. So the main bits of data that we're going to be modeling. Then we've got relationships. So these are the arrows with the name above them, and they're effectively the equivalent of the join. So not the primary key foreign key relationship, the actual join. And the difference in a graph is that the join is actually persisted, so it's stored at write time rather than calculated at read time. And we can give a name to it. So in this case, the name is has topic. So group has topic, and then we put the topic on the other side. And with these names, you try and make it so that if you read it out, so group has a topic, and then you list the topic, that it sounds like a reasonable English sentence in this case, or they'll obviously substitute that for the language that you're using. And then the next bit of terminology to remember is labels. So these are the things highlighted inside the nodes, and these are a way that we use. These are used to tag the nodes so that we can quickly go and find them later on. If we want to do a query where we look up a node, we can make use of the label to allow us to zoom in on the particular type of node that we're looking for. So for example, if we say, I want to go and find the Neo4j group, or I want to go and find the Neo4j topic, I can make use of the label and then associated indexes to find it more quickly. And then finally, our last bit of this diagram is we've got properties, and these are highlighted to the left of the group and above the topic. And these are key value pairs of metadata or attributes that we can store. And so on this diagram, we've got them stored on nodes, but you can also store them on relationships as well. So for example, we could put them on the has topic relationship, although I couldn't actually think of a property to put on there, so that's why there's nothing. Okay, so that now leads us to our query to answer the first question. I've skipped out importing the data. If you want to know to see all the scripts that do this, it's all on a GitHub repository, which we can share with you afterwards. But for now, we're just going to focus on the modeling and the querying. And so what we're doing here is we're saying, okay, I want to find the similar groups to Neo4j, and remember down the bottom right-hand side, we've got the diagram of what we're trying to do. And so we can start now and write our query. So if we read this from left to right, we're saying we're using a match clause. So match says, hey, I want to match a pattern, and I want you to go off and find me some results. And in this case, the pattern is, well, the first thing needs to be a node, and it needs to be the Neo4j London user group node. So we're saying it has a group label, so this is the group label, and then it matches this property with this value. Once we've got that, then we're going to follow the has topic relationship. So we're going to go Neo4j has a topic. What is the topic? Okay, let's capture that here. Then we're going to follow from the other side of that topic and see what other groups have got the topic. And so now effectively we've got a long list of groups that have similar topics to us. But what we want to do is sort them in some way. So we want to kind of say, well, which one is the most similar one? What's the one I should recommend? Which group should I be recommending? So now we do a bit of aggregation. So we're doing a count on the topics. So saying, well, how many topics in common are there, and what are the topics? So that's what the collect line is doing. And one thing different than SQL that we're doing here is that we're using an implicit group by key, which is the other group name. So we don't need to specify group by other group name. It's implicit because it's the only non-aggregation function in the set of return values. And then similar to SQL, we're doing a bit of ordering and we're doing some limits as well. Okay, so let's see what does that actually look like. So if we were to execute that query in Neo4j on this data set, this is what we'd get back as the similar groups for the London user group. So it comes back with, for example, Python for quant finance is in first place, and that has 8 topics in common, and then we get a list of those topics over here. Okay, so that's our first question answered. And the main thing to take away from this is that we only need to build the model to answer the question that we have in front of us. So I'm sure when you saw at the beginning, like, oh, cool, we're modeling Meetup. There's lots of different bits of data in Meetup that we could import. So they've got events, they've got RSVPs, they've got locations, they've got people. But the first question we had was only show me similar groups. So we didn't need that data yet. And this is a common approach when you're modeling stuff in graphs, is that you don't necessarily need to model the whole thing up front. You can just start with the first question and then evolve it as we go on. And that's what we're going to do in this demo. Okay, so I looked, so had a look at the output of this query, and I realized actually it's good. It does find the groups similar to the Neo4j one, but I happen to know that I'm already a member of some of them. So for example, I'm already a member of the London Postgres one, and I'm already a member of the Hadoop users group. So it's not actually that useful at the moment. So one of the ideas of recommendations is we don't suggest you something that you already have, or in this case already are a member of. So we want to address that, which means we need to go and look for some more data. And so Meetup exposes a couple more things. So they give you the your meetup, so you can work out which meetups am I already a member of. And we're going to cheat a bit, and we're going to download the interests as well, which we're going to use for our next section. So we're going to pull down the meetups and in people's interests, which then moves us on to our next question, which is just a slight modification of the first one, which says, so I'm a member of the Neo4j London group, and I'm quite liking going to those events. I want to find some other similar groups, but this time make sure that I'm not already a member of them. So your last attempt showed me a couple of groups that I'm already a member of. I don't want any repeat of that. Okay, so we need to, first thing we need to do, we need to update our model. So you'll be familiar with the first bit we've already done. So we've done the group and the has topics. And so what we're adding in is the member of, this bit down here on the left-hand side. So what we're saying is that we've got a member and they're a member of a group. And so we're going to add that membership in. And then we can, so we'll write a script, we'll import that data, and now we can update our query to take that into account. And so the simplest change we can make is actually leave all of it the same and just add in this extra return field in our results. And what it's saying is exists. So exists is a function in Cypher, and this lets us find out whether, in this case, a predicate exists in the graph. So what the predicate in this case is, I want to find a node that has the label member, has the name property Mark Needham, so that i.e. me. So find me and check whether I have a member of relationship to the other group. So this is the other group. And if I do, then we're going to return true. And if it can't find any relationship, then we're going to get false. And we'll call it already member. And so if we run that, then we get back some result that looks like this. So I've still got the same result. So it's still showing Hadoop users group UK. It's still showing Postgres. It's still showing import IO. But now it has a true value there. And so obviously that leads us to the next query, which is, well, okay, that's cool that you can tell me I'm already a member, but just don't show me it. And so the way that we're going to make that happen is by making use of a where clause, or in this case, where not. And so the match clause is used for going and matching patterns and finding more stuff to return, and the where clause is used for filtering as we go. And so in this case, we're saying I want to do my query, go and find me all these other groups, but actually filter it out if I'm already a member of it. And if we run that query, you can see now we've got no Postgres, we've got no Hadoop, we've got no import IO. So we've only got groups that I'm not a member of. And so that's our second query. So what we might do next, so the first two queries were focused very specifically on similar groups. So find me the Neo4j group and then find me groups similar to that. With recommendations, where we typically go after that is actually probably we want to start suggesting things for the user, for the logged in user. And so what we're going to do next is actually make suggestions to a user of other groups they might be interested in based on ones that they're already a member of. Which now allows us to make use of the interested in relationship, the interested in data that we pulled down before. So when you sign up to Meetup, as part of creating your profile, you can fill in interests. So you can say, I'm interested in Neo4j, I'm interested in Java, I'm interested in big data, or whatever it is your interests happen to be. And then Meetup can then obviously Meetup can make use of that data, presumably to make recommendations, but we can also make use of it in this demonstration. So we know that you're interested in some topics, and so maybe we can make use of that knowledge to make suggestions. So what we're going to do next is we're going to make use of that information. So this query is similar to the previous one, but this time we're weighting it based on what you've said your interests are. So the first part of this query says find Mark, then find the topics that Mark's interested in, find the groups that have those topics that Mark's a member of. So we're basically checking, like I've said, I'm interested in these topics. Have I gone and joined groups that confirm this interest? And then what we then make use of a with clause here, and so that captures the member, so that's me, and it will have lots of different topics, and we give kind of a weighting to each one. So if there's 20 groups that I'm a member of that have a topic, then I get a score of 20. If there's 10, then I get a score of 10, and so on. And so once we've got the topic, we then go and find other groups, and remember again we check I'm not already a member of those, and then we order those, but this time the recommendations are specifically for me, and the second bit is we're using this sum variable here, or some function rather, to order them. So we're kind of every time if I had open source as one of my topics and it comes up 20 times, every group that shows up with that is going to get that multiplier. And so if we run it, this is what I would end up with. So I get some slightly different results than the Neo4j group. So you can see that my interests my interests that I specified are very centered around data-related meetups. So it's suggesting the PyData meetup, the data scientist meetup, the data science lab, and some other ones. And then in the second column we can see, well, what topics was it that I specified an interest in that have resulted in these suggestions. And obviously this score you probably wouldn't show it, but we're just using it to sort and show some results at the top. So that works well for me. Unfortunately, when I tried it for my colleague Jonny, it didn't come up with any suggestions at all, which was a bit disappointing. So I thought, oh, what have I done wrong with this query? And so I started breaking it down, like taking parts of the query out. And I realized that Jonny actually doesn't have any interests. Now, obviously, Jonny does have interests. It just happens that the Meetup API has not exposed any of his interests. And the reason for that could be that you didn't specify any, or it could be that you've chosen to hide them in your privacy settings, and so no one else can see them. And I think this is quite an interesting modeling problem, because you've kind of made the assumption, oh, definitely everybody's got interests, and I can write this query to find suggestions for them. And now I'm showing 0 rows to the user, and so they don't see any suggested groups, and so obviously they don't have any recommendations to follow. But the nice thing about modeling this data as a graph is that it makes it really easy for us to find an inferred relationship. So remember, we've got members who are members of a group, and a group has a topic, and we can kind of imply that perhaps by being a member of groups with different topics, that means that we've got a missing interested in relationship. So we've kind of got an interest, but we never actually wrote it down anywhere. And so we can actually use this to help make some recommendations to Jonny. So in other words, there's an implicit interested in relationship between topics of groups I belong to and I haven't expressed an interest in them. So what we're going to do is we're going to make that relationship explicit. So we're going to move from this diagram on the left, where we've got people are members of groups and groups have topics, and there's an inferred interested in relationship, and we're going to put it into the graph. And the way we're going to do that is by writing a query like this. So this one's what it's doing is it's going over all the members in the graph, and we're finding which groups are they members of, which topics do those groups have. So that gives us like a load of rows. Then we're doing some grouping. So we're saying get the member, get the topic they're interested in, and work out how many times that topic's showing up, so i.e. how many groups have that topic. And then filter it if it's more than 3. Now, the number 3 is kind of an arbitrary number. I just did a little bit of checking on the data, and 3 seemed like a reasonable thing to claim interest. We can obviously do a different number. And then what we do here on the last line is we're saying, well, once we've found those, we've got those pairs of members and interested topics, let's create a relationship between the member and the topic. And so we put in an interested in relationship. In this demo, we make the interested in relationship that we're creating look the same as the one that we got from the API, but we might choose to actually put like some sort of property on here to say hey, actually, this one was inferred, and so then maybe we could choose to display that differently on the UI of our application when we show it to the user, and perhaps we could get them to confirm whether they like the suggestion, or they could perhaps even rule it out and say, no, 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 I'm definitely not interested in that topic. So that's another area that we could choose to explore as well. But the main thing is here is that it now allows us to make some suggestions for Jonny. So he didn't have any interests, so we've had to go and work them out. And we've actually worked out Jonny is quite interested in a bit of big data, open source, visualization, and data analytics. And there's some groups suggested for him as well. And they're different than the ones that I have. So he's got Python for Quant Finance. He's got the Analytics Club, some BI ones as well. And so the tip here is that sometimes there are missing links in the graph, and this data isn't actually stored anywhere. So the fact that Jonny's interested in those topics isn't on Meetup. It isn't actually stored anywhere. He might not even think himself that those are the topics that he's interested in. But we can work it out by having a look what other relationships does he have. And obviously with this type of query, in this data set I'm working with about 30,000 people, and so I can just run it all at once. If you were working with a bigger graph with a bigger set of members, you probably want to batch it up and do a chunk of the members at a time, so that you avoid loading the whole database into memory. And there's two approaches that you can take to keeping this up to date. Probably the simplest operational one is just run it once a day, because interests don't change that often, and so probably the granularity or the freshness of having your interests up to date to midnight yesterday is probably enough for most applications. If we needed it to be more accurate, we could maybe write queries that go and update it on a per user basis. So if I join a group, go and update my interests. If I leave a group, go and update my interests. Or maybe there's some other appropriate way of doing it as well. Okay, so that's sort of finding relationships that don't exist. The next thing I wanted to do was a feature similar to what LinkedIn does. So I'm not sure how many of you are familiar with LinkedIn, but on LinkedIn, when you go to a company page, on the right-hand side, it has a little box that says, "Oh, people who after they were at this company, they joined this other company." And so I thought it might be quite interesting to do that for the meetup groups as well. So after people joined Data Science London, they joined insert group here. How can we write that query? And so we can actually do it. So here we don't actually have to check. We don't have to change the model. So the model already allows us to do it. And what we're doing here, so if we go from the top left down, we're saying I want to find the Neo4j London group. Then I want to find the people who are members of it, and then I want to find the other memberships that they have. So we're going finding all our members, find all their other memberships. Then we're going to do some filtering. So we want to filter. We want them to join the Neo4j group first, and then join the other groups afterwards. So if they join some groups before the Neo4j one, we're not interested in those for this query. So that's what this where clause is doing. So it's filtering out groups that we joined before the Neo4j one. Once we've done that, then we're doing a bit of a collect. So we're getting for each member, can we order effectively the next groups that they joined, and then we're going to grab the first one. So we're kind of collecting all the other groups they joined, and we're just picking the first one that they joined afterwards, because our query is find the next one they joined, and then we're going to get back. We're going to get back what is the most common next group that people are joining, and how many times are they joining. And so if we run that for the Neo4j group, this is what we get back. So it shows that after the Neo4j group, the most likely one people are to join is the Data Science London, followed by Cassandra, and then you can see some other ones in there as well. Okay, so that's cool. So we've been able to answer the query, so it's actually worked fine. But it's a little bit like, kind of felt a bit clunky writing the query, and it's probably a little bit inefficient as well, because the only membership we're only really interested in in someone's Neo4j membership and the next one after that. So we're only really interested in 2 memberships per person. We've ended up having to scan all of them to work out and then sort them to work out which is actually the next one. And so when you start to find yourself doing that, when you start to see that your queries are starting to resemble sort of doing scanning of data rather than making use of a graph structure, it might be the case that actually we're missing a concept, and we want to try and pull that out. And in this case, the concept is membership. So can we actually model membership and make that a first-class citizen of our domain? And so the pattern is that facts can become nodes, or if in this case, like something that we originally model as a verb between two nodes might evolve into a first-class concept on its own. So this was, if you remember back a bit, we've got members or members of a group. What we might choose to do instead is to say, well, actually, a member has a membership and make a specific node for membership of a group. So we kind of add in an extra node between the member and the group. And we can then refactor or migrate our existing model towards that one. So at the moment, we haven't deleted the other ones. We're kind of keeping both of them side by side. But what we're doing is find members who are members of a group, create a membership node, and we're going to use the combination of member ID and group ID as our key for the membership. So we'll create the membership, and then we'll join it. So we're kind of joining that little triangle. So we go member into has a membership, and membership is off a group. So now we've got that created. And the next thing we want to do is we want to go and find like what is your next membership after this one. So we want to create a relationship between the memberships that a user has. And so we can write this query to do it. I probably won't go into the details for this. You can obviously have a look at it afterwards. But effectively, we're just ordering the memberships for a specific person, and then we're joining each pair of adjacent memberships together. And what that does is that now allows us to write a bit of a simpler query to find the next group that people join after the Neo4j one. So if we go through this query, so we say find me the Neo4j group, find the memberships of the group, then find the next membership, and make sure that these, make sure that the memberships are for the same person, and make sure that they're for the group as well. And then what we get back, if we run that, we'll get. I mean, the result will be exactly the same. And this is what the two. So now we've got these two models. This is what the models look like side by side. And you can see this one's a little bit shorter. So we've reduced the amount of code, although the model is a little bit more complex. And so what we might want to know now is, well, which one is better? Which one performs better? Is there any benefit to the added complexity of what we've just done with this refactoring? And so with Cypher, there's 2 ways of profiling your query. So you can either profile them and run them at the same time. So that's the profile keyword. Or you can see what does it think is going to happen when it executes the query. And so you can use the explain keyword to do that. And that will not actually run the query. That will just tell you, based on the statistics that the database has, what does it believe is going to happen if we run this query? What operators are going to be called? So this is what a query plan looks like. This is the longest one that's been posted to Stack Overflow. So I wouldn't suggest this is something to aim for. This is just something that you to see. This is what you can do. So it's 3 pages long, but effectively this is what you get. So you get to see operators, how do they combine together, how does data flow through them, and then there'll be some estimated rows telling you how many rows there are in that part of the query, and you'd also see a metric called DB hits as well. And our goal is when we're tuning queries is to get that number down. So it's an abstraction of how much work is being done by the database, and it doesn't take into account caching or like how warm are your caches, or am I going down to disk to get this data? It's just purely an abstract unit of work. And so we can compare our 2 queries against each other. So we've got both the models in there. And so if we run the profiler over this, it will tell us that the first model, so the one we did with the scanning, has 100,000 DB hits, whereas the second one's only got 23,000. So we've reduced the number of hits by 5 times. So let's say it's 5 times quicker. In this example, it roughly is. Which leads us to the tip. So the tip here is actually try some different models out and see which one performs the best. And there can be, I mean, one of the properties of performance is how quick is it, but another one is equally, well, how complex have we made our model by making this change? Is it worth it, or do we just say, okay, it's actually better to get a bit more a simpler model that more people can understand rather than one which is really, really fast? And so you have to make these trade-offs as you go. Another trade-off that we might think about making is, well, at the moment we've got both of them. Should we just keep both of them? And that's certainly an option. The disadvantage of doing that is obviously now we've got to keep both of them in sync, and that becomes an invariant of the application. So the application knows that this member-off relationship is equivalent to this off group and has membership relationship. And just because you go and change this bit doesn't necessarily come with it. So we'd have to make sure from our application that we keep it in sync. And so this is, for example, this would be a query of how we could do it. So if we're adding a new group, we could, so let's say we get a new group coming in, the way that we could add it would be, this would be a query that adds it in both models. So first of all, it goes and creates a member-off relationship, and then it also creates the membership triangle as well. And we could do the same if we were removing a relationship. So if we know that we want to get rid of one, we could go and find the member-off one, find the has membership, and delete that as well. The disadvantage being that if you only had one of the models, you'd only have this chunk if you were doing the member off, and you'd only have this chunk if you were doing the more complicated model. And so we might think, well, we know that has membership was faster. It was 5 times faster when we measured it, so we might as well get rid of that member off relationship. But we might not want to do that so quickly. So remember the first query that we did where we were trying to find similar groups that we're not already a member of? This is how it looks if we now put the two, so you'll be familiar with this query. So this is the first version of the query. This is the more where we've got membership as a first class citizen version of the query. And if we compare them side by side, the DB hits are now inverted. So the second one actually is now almost 5 times as expensive as the first one, because here we're just doing some counting. So we're only all we care about is the membership. We're not actually what memberships do you have? We don't actually care about the relationships between the memberships. And so now we have to go and traverse more ground to get the same result. And so we have to make a decision. So different models work better for different queries, and they might be worse for others. And so we might, and what works really well for reads might mean that we've got a write and maintenance penalty. And so we have to decide like which one of these makes more sense for the application that we're building. So what about events? So this is one of the main chunks of data that they've got on Meetup is making event suggestions. And so we might want to start off with a simple query. So we'll just suggest events for groups that you're already a member of. And so we're going to introduce a couple of things. So we're going to introduce a link between groups and events. So a group can host an event. And we've also got RSVPs in as well, which we're going to use in just a bit. And so we might write our first query. So we're trying to suggest some events to me based on the groups I'm a member of. So we've got to find me, find the groups I'm in, and find the events that are being hosted, and make sure they're in the future, and that I haven't already RSVP'd to them, and then return them. And so I get a few suggestions. I might choose to then add in previous events. So, but this seems like it would be a reasonable piece of information to tell me. So, like when I'm trying to make the suggestion, it's quite likely that I'm going to go back to the group that I've been to before. So maybe I can go and check, well, which groups have you been attending events of, and let's show that in the results set as well. So we've just added in this bit here, which is go and find the events that I've RSVP'd yes to that are in this group. And then we get it in here, and obviously you can see my interests are quite narrow according to this this table. But so we've got an event, we've got a group. It tells us if we're a member, and we've got the number of days till the event, and we've got the previous events as well. We probably wouldn't show that on the eventual on the UI for our application. We could use this information to work out what are we going to show. So while I was doing this, I was quite curious because I imported all the different RSVPs. So I put RSVPs with yes, with no, and with waiting lists. So those are the three options. But then I realized that I was actually nearly always only interested in finding ones where someone had responded yes. So I was curious, well, if I actually make these relationships more specific, so if I call it RSVP yes, would that make any difference? Because Neo4j is really optimized for querying by unique relationship types. So sort of down at the storage level, this is what it's intended for. And so by sort of using this property, I thought, oh, maybe I'm slowing down how fast this query can go. So I did a bit of refactoring. So I wrote a couple of queries that you can see here. So I go and find all the yes RSVPs, and I make them use this new relationship type where the yes is in the relationship name, and I do the same thing for the no's. And then I change the query to have a look, well, how much difference does it make? And it was a little bit. It's probably, what is it, about 15%, maybe 10-15% less DB hits by using RSVP yes compared to RSVP. And the reason for that is that when we come to look at the RSVP relationships, when you're grouping, it's able to look only at that group, so it can ignore the RSVP no and the RSVP waiting list. So we reduce a bit of the scanning that might happen. Whereas in the first one, we look across all RSVPs, and then we compare the value of the response property and check that it matches yes. So it's a little bit faster, but it's probably not, at least if this is the only query that we're doing, it's probably not worth refactoring to there. But if we wanted to, there are reasons why we might like, why each of those models is preferable. So if we're going purely for performance, then we might choose to go for the specific names, even if it only gave us a little bit of a gain. But if we were building a page where we want to show all the RSVPs, so I'm like, hey, let me show you, as a user, here's all the responses that you've ever done. If we're using RSVP and we've got the actual response as a property, then the query is quite simple. So we can just say, hey, find the RSVPs for Mark and find the events, find the groups that hosted those events. But if we split them out, we've now got to list each one separately. And if there happened to be another response other than yes, no, and waiting list, we've got to go and update our query to take that into account. So that's a bit of a disadvantage of using the more specific ones. And again, it's sort of again, there's a bit of a trade-off to make. So make your relationship types specific, but be aware that sometimes there's a bit of a maintenance cost that you might have to pay for getting really specific. So the last bit that I decided to add was actually, can we find the friends graph that's sort of lurking within meetups? So there's probably a load of people who go to meetups who know each other, but there isn't any system that's captured that. All we know is that people RSVP'd to events, and that might infer that they know each other. So what we can do now is we can write a query to work out which people might know each other. And this is me using a completely made-up formula that I created that says, effectively, if you went to a meetup with 10 people, there's a 1 in 10 chance that you might have met each other person each. Whereas if there's 50 people attending, then there's a 1 in 50 chance. And then we just make up a score based on that assumption, and we store that as a friends relationship between people. But they've got to have attended five or more events in common to even be considered friends at all. And so this leads us to an interesting thing. So if you were the eagle-eyed amongst you might have noticed that we didn't specify a direction on the friends relationship, so we left it blank. And so what will happen there is that the relationship will be created in a particular direction. And so if we run this query and we got say me on this side and Corey on this side, and it created the friends relationship, then then when we process Corey, it would realize that actually there's already a friends relationship to Mark, so there's no need to create it. And the reason that we do that is because we know that friends is a bidirectional thing in this domain. So if I'm friends with Corey, then Corey is friends with me. Now Neo4j always stores relationships with a direction, but you can choose to ignore it when you write your queries. And the speed of searching for incoming relationships is the same as searching for outgoing. So there's no performance penalty from doing this type of thing. And if we wire that into our query, so now we've got the sort of two optimizations. So we're going and finding, are there any of my friends who have RSVP'd yes to this event? And we can go and find those people and see how many of them there are. So in this case, so now I've got top recommendation is saying, you've been to 94 events for this group. There's 7 topics that you might be interested in for the group, and you've got 5 friends going. And perhaps we might then list who those friends were as a final step. And so the tip here is that some relationships are bidirectional, but it's an invariant of the application. So Neo4j always stores a direction, and we can choose to ignore that. I'm sure you can probably think of some bidirectional relationships in the domains that you work in that might have similar characteristics to the friends one that we've got. So just a quick TLDR. In case you missed anything, so these were the tips. So first thing is model incrementally. So hopefully you've seen that that's what we've done throughout this talk. So we started off with a query where we were just looking at similarity between groups. Then we introduced members. Then we introduced people's interests. Then we introduced events. Then we introduced RSVPs. And along the way we built in some other things. We built in a kind of a latent social graph as well, and we found out interests of people who didn't have them. We've also been profiling our queries, and I recommend that you give that a try just so you can see what's going on under the hood. Consider making the implicit explicit, but be aware that sometimes that might not be the best option, and perhaps having a slightly slower query, but having an easier set of queries to maintain might be a better option. Where you can be specific with relationship types, so don't go and name everything connected to or has. You want to be reasonably specific, but obviously we've kind of talked a little bit about, well, how specific should we go? And then for bidirectional relationships, you can just choose to ignore the direction when you're writing your queries. And as I mentioned, that the data was available if you want to go and see how the scripts worked and how it parsed the Meetup API. That's all available here. So if you don't capture this, but if you don't capture this URI, don't worry. Corey will send that out along with the link to the recording in the next few days. And with that, I am done.